Question number 82 in the multiple choice section says, let f be a function such that f of 1 equals -2 and f of 5 equals 7. Which of the following conditions ensures fc equals 0 for some value c? So if I sketch a quick diagram here, at x equals 1, y equals -2, and at some point x equals 5, y equals 7, so it looks like this. And we're looking for where the graph crosses 0. Okay, so f of c equals 0 in this interval. So we want to know if it crosses the line in this 0 line in that interval. And really what we're looking at here is the intermediate value theorem. All it needs to do, it could be jagged, but as long as it's continuous, we know that some value c must exist. So the answer is C. So be very careful with these problems, because sometimes if this says something like this, f prime, if it relates to f prime, now we're talking mean value theorem, and that needs to be continuous and smooth. But in this case, we're just talking about f, so we're talking about intermediate value theorem. Question number 83 says, acceleration of particles given by this function, t minus 8 times sine t, and it asks the value of the particle, the value of t, where the particle's velocity is decreasing most rapidly. Okay, so what this means is velocity decreasing most rapidly is when a prime, or a, is at a minimum. So this is a graphing calculator problem that all we really need to do is graph a, which I have here, and we want to find out where it's minimum. And if I graph a, I get this graph, and I can see that this point here represents the absolute minimum of that in that interval. Okay, so we do calc minimum, and we can find that value. It ends up happening at 1.42. The alternative to this is to do a derivative, and we can find out where the derivative is equal to 0. So I can do the derivative of the a function. So a prime of t, where that's equal to 0, we find max min. Okay, so if I do that, there's my a prime of 0 here and here. I know that I'm going from negative to positive here. So in this direction, we're going from down to up. Okay, so that's going to be a minimum point when we talk about the a function. Okay, so it's going to go like this, down and then up. So that represents our min, whereas in this case here, this would be from positive to negative. So this section in here would represent a max point. So again, we're looking at there, and notice that the max point would have showed up here on the original A graph. So again, it depends on how you want to do this, but it may be easier to look at this as the minimum of the actual graph that you've been given.